exponential functions. And all that really means is that we have a function where the variable is in the exponent. So this x is my variable, so the variable, and b is some base, some number, some base. So we're talking about things like, so example, and I'll put non-examples over here. An example of an exponential function is something like 2 to the x, or even 10 to the x, or even I can have a base of 1/2, that's fine. And 3 to, then we could add some more stuff in there. I could even multiply something on the outside. All of that is okay. The things that aren't okay, b has to be bigger than 0, and it also can't be 1. And let's talk about why that's true. If I had 0 to the x power, that's just 0. What about 1 to the x power? That's just 1 over and over and over. If I have a negative number to an exponent, like -2, this one is very strange because when the exponent is positive, when it's odd, I'll get a negative answer, but if the exponent is even, I'll get a positive answer. So this one goes negative, positive, negative, positive, negative, positive, back and forth and back and forth. So that doesn't really work. The other one that would be a definite no-no is x to the x. Well, if I don't know what the base is and I don't know what that's a lot of unknowns. So those are some non-examples. Now we're going to be able to do a few things with these. We need to be able to evaluate them and graph them. So the first thing we're going to look at is evaluating. And I apologize if you hear the background noise a little bit. The video, another video is processing, and this laptop is a little loud. F of x equals, let's see, 42.2, 1.56 x. And let's say this models average amount spent at the mall after X number of hours. They may ask you questions like, how much was spent after 2 hours? Well, all you're going to do is, since x is the number of hours, we're going to replace x with the 2. And you can type this into pretty much any calculator. Desmos works fine for this. I'm going to use my graphing calculator just because I have it handy. 42.2 parentheses, and you would type it into Desmos basically the same exact way. And I'll show that on the next one. I'll use my Desmos on my phone. Point, and that's 697, so that would round up to 70 cents, because if we're talking about money, we want to make sure we're in money. My Desmos. What if the next one says, well, what about after 3 hours? Well, then we're just going to replace the x with 3. I'm going to pull up Desmos on my phone. If you didn't know you could put it on your phone, yes you can. 42.2 parentheses, I don't know if you can see that, 1.56 parentheses, and then I want the exponent. So I'm going to go up to where it says squared, but then I'm going to go and change that. I press the back arrow, and now I can delete the 2 and change that to a 3. And it puts my answer at the bottom. 160.21 would be to 2 decimal spaces, and since I'm talking about money, that's what it would be. We also want to look at graphing. And again, I could use my graphing calculator to help out. But I'm going to do a little bit of a table here. We can actually make a table in Desmos. So I'm going to use 2 to the x. And let's make a table 2. We can look at the graph and we can look at the table. So I'm going to go in here. I'm going to delete this out. And I'll zoom in a little bit. So I'm going to do y equals 2. And I wish if I had a, see, this is not, I wish it had like, nope, that's not what I wanted. The little caret button like I have on my calculator, that would be nice, but it doesn't. So I had to go 2 squared, and I'm going to go up here and back arrow and change that to the x. And we get this graph. If you remember, that's an exponential graph. I want to look at the table. So I press the settings thing, and I'm looking at the table. And so when x is -2, it's at 0.25. And let's talk about why that's that. Because 2 to the -2 would be 1/4. It's 0.25. At -1, it says 0.5. And that's because 2 to the -1 would be 1/2. 2 to the 0 power is 1 because 2 to the 0 power is 1. 2 to the first power is 2. Then 2 squared is 4. Now, as I go further and further this way and get more and more negative x values, I'm going to get fractions. And they're going to be really, really tiny fractions. So these are all reciprocals of what I have here. And as I go this way, it's going to get bigger and bigger and bigger really, really fast. So looking at the graph and looking at the table, we end up, let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So when x is 0, I'm at 1. Then I'm at 2, then it jumps to 4, then the next one will be at 8. It's going to jump really, really high. This way it's going to go 1/2, 1/4, 1/8, 1/16. It's never going to actually reach 0. It never reaches 0. It gets close, but it never reaches. This is called a horizontal asymptote. So I have a horizontal asymptote at the x-axis. So at y equals 0. It never reaches 0, so that's where the horizontal asymptote is. We can see our y-intercept pretty easy. There's my y-intercept. Is at 0, 1. I don't have any x-intercepts. That's interesting because it never hits the x-axis. My domain Well, I can plug in negative x values, positive x values, so it's going to be negative infinity to infinity. The range, however, I'm only getting positive numbers back, and they don't reach 0. So this is going to be 0 to infinity. And notice I don't put the bracket on 0 because it does not ever touch 0. So what's going to happen if I change that to be a 1/2 to the x? Well, I'm going to start in the middle. What's going to be 1/2 to the 0 power? Well, anything to the 0 power is 1. 1/2 to the first power is going to be 1/2. 1/2 squared is 1/4. But what happens when I go backwards? 1/2 to the -1 is actually going to flip it. It's going to turn it into a 2. And then 1/2 to a -2 is going to flip and become a 4. So this is kind of a flip of what we just had. So that first one was an increasing graph. It was growing the whole time. This one's going to be going down. So -2 is going to 4 this time. So -3 would be going to 8. Woo, way up there. And it would go to 1/2, a 1/4, an 1/8. Again, it's never going to touch 0. So we have a very similar graph. It's just kind of flipped. So this one is decreasing the whole time. The domain is still going to be negative infinity to infinity. The range is going to be 0 to infinity. X-intercepts, none. And y-intercept is going to be 0, 1. So what do you think is going to happen with this one? Is it going to be increasing or decreasing? It's going to be increasing. Good job. Three to the 0 would be 1. 3 to the first is 3. 3 squared is 9. If I go backwards, I'm going to be dividing by 3. It's going to give me fractions. I'm going to put a couple of extra little dashes because I'm going to do something extra in a second here. So I'm going to put this one in, go ahead and do this in black. 4, 5, 6, 7, 8, 9. Wow, it's way up there. Again, same domain, same range, same y-intercept. Everything's the same. What would happen if I graphed 3 to the x plus 2? Let's think about how our functions move. What would happen to that graph? Well, the plus 2 at the end means it's going to go up 2. So I'm going to take every point and go up 2, up 2. And even this horizontal asymptote would move up 2. So this would be almost everything's the same. The range would change and my y-intercept would change because the horizontal asymptote is now at y equals 2. Now what would be going on if, whoops, I did, let's keep that plus 2, but I changed this to an x minus 3, then a plus 2. Well, we still have the up 2, but what does the x minus 3 do? Well, that's going to move me right 3. So we'd already moved the up 2. We're going to move 1, 2, 3 steps to the right. So this one would look something like this. And the beauty of these graphs is you can check them in the graphing calculator. Now I'm going to stop this video and I'm going to record another one that talks about a really, really special base, and that's base E.